Hi, this is just a bonus example with separation of variables. Realize that this is a problem that's going to come up on this week's worksheet. It's going to come up in chapter 3. Figure we should do an example. So this is clearly separable, right? I can separate the y's onto the left-hand side and be left with just a dt on the right-hand side. So, and it's also nonlinear. So we're going to use the separation of variables technique on it. The first thing I'd like to do is get rid of the fraction by combining those terms with a common denominator. So we're left with 2y times 3 minus y. Now we separate the variables, so dy over 2y times 3 minus y equals dt. To integrate both sides is what we'd like to do next, and we need a partial fraction decomposition in order to do that. So let's do the partial fraction decomposition in another color. And we're going to have a over 2y plus b over 3 minus y equals 1 over 2y times 3 minus y. And our multiply both sides by the common denominator. We have a times 3 minus y plus b times 2y equals 1. If I set y equal to 0, then the b term goes to 0, and we're left with 3a equals 1, so a equals 1/3. And if we set y equal to 3, then we get b equals 1/6. So back to the integral. We have an integral of 1/3 times 1 over 2y, so that's 1 over 6y plus 1/6 times 1 over 3 minus y dy equals the integral dt. And having done the partial fraction decomposition, we're left with something that we can manage. So this is 6 times, oh, it's not 6, 1/6 times the natural log of y minus 1/6 times the natural log of 3 minus y. There's a sign change there from the chain rule, or if we did a chain of variables on this, we could do u equals 3 minus y in this part of the integral, and the du would give us a sign change. Equals t plus c. So this is an implicit solution, which is good for some cases, but we're going to be asked to actually solve for y, because in chapter 3 with this type of problem, we're going to care about y. It's going to represent a population, and so we want to know y as a function of t. So in order to do that, we're going to have to use some log rules. Let's do this first, though. Let's factor out the 1/6. Now I can multiply both sides by 1/6. And on the left, I'm going to combine these terms using a log rule, right? The log of a minus the log of b is equal to, let's write that log rule down actually, log x minus log y equals log x over y. That's a log rule that we can use here after multiplying through by 6. So we're going to get log of y over 3 minus y equals 6t plus 6c, which I'm going to replace with just c. I'm just going to call that c. So it's starting to take some form here. Now to get rid of the log, we exponentiate. So e to all that stuff, the exponential and the log function cancel. We're left with y over 3 minus y. In the context we care about, this is going to be positive, so we can drop the absolute value. This is going to be e to the 6t plus c, which exponent rules now tell us is e to the 6t times e to the c. And I'm going to take e to the c and going to call that a new c. That's just a constant to a constant, so that's a new constant, which we're going to label as c. So we now have y over 3 minus y equals c e to the 6t. So it's starting to look simpler, but how do we solve for y still? Well, we're going to have to get rid of the denominator. So multiply both sides by 3 minus y. That is 3c e to the 6t minus yc e to the 6t. Okay. Now putting everything with a y on the same side, we have y plus yc e to the 6t equals 3c e to the 6t. Factor y out of the left-hand side. 1 plus c e to the 6t equals 3c e to the 6t. And finally, divide so that y equals 3c e to the 6t over 1 plus c e to the 6t. And we're there. And this last step, I want to explain at this point why we didn't replace 3c with a new constant. If we'd replace 3c with a new constant, we'd have two different c's, right? And we can't do that. I could have replaced 3c with a new constant, called it d or something, but I like having just one constant in the end, 1c. So we left it at that point instead of rewriting 3c as a new constant. So this is the solution, y of t. There is one thing that sometimes textbooks like to do, or just people in general. You can multiply the numerator and the denominator by e to the minus 6t. And if you do that, you get y equals 3c over e to the minus 6t plus c. And sometimes that's a preferred way because there's only one exponential in the answer instead of two. But they're equivalent functions. Plots, of course, look the same. Evaluate them, they're the same. So they're totally equivalent. It's just a matter of preference at that point. But I want to do this example because there is a lot of algebra involved. We had to use log rules. We had to use exponent rules. We had to factor, divide, manipulate, move things around. And that was all after the calculus, all after the partial fraction decomposition and the integration. We had all of that algebra to do to be able to solve for y, and I wanted to show those steps to you.